Hi, good day to my lecturer, Sir Rizwan. My name is Nofiki with matrix number EA20013. So today I would like to present a demonstration on a project assigned, which is the power system study IEEE 37 bus system. So from the project requirement here, we could find that I should model a transmission system network by using any suitable software. So in this case, the software that I choose is the ETAP because it is a very reliable power system study application and it can generate a very complete report for us to analyze and to identify the bus system. So from the next requirements here, I will at least able to compute the load flow and short circuit calculations. And from the requirement here, we also can see we should prepare a base case in accordance to a reliable reference. So from my case, the base case that I choose is the IEEE PES test feeder, in which the system that I refer is the 37 bus feeder, and actually it is actual feeder in California and it operates with 4.8 kilowatt voltage. And actually, this circuit configuration is fairly uncommon because it is a very unbalanced bus system. So in real life, it is ready to use. And so next, let's go move on to the demonstration of my power system bus. So I open my project and open a sketch that I did. Okay. So here is the circuit that I constructed by using here the edit. So the power grid that I use is this, and this is the transmission line that I choose is this, the transmission line, and the lump load, and the bus bar, which is this, the bus. So from the components here, we can see the summaries because the bus that I choose, the bus that I named lead 701. So when I choose this, actually it will point us to the different color, so we can easily to identify the component. So after I construct this circuit, I can perform the analysis by edit the data inside the lump load. Like the short circuit, I should set it to the S and the MW, and the nameplate I should put the suitable value to it, and the transmission line, each of the bus bar. So I should put the value for it, and then next I could generate the load flow study. So here is a load flow study button, and then as I run the load flow, the case study is here, and this is the study that I put before. So when I run the new one, I should put the name for it, this one, and I choose the load flow output so that it could generate the output. And this is the notifier. It will notify the under voltage condition and over voltage condition. So in this case, the system that I constructed, it got this bus, it is under voltage. Actually is percent operating is quite okay, so it is not that worst situation. So actually it is still okay for us to use. And then from the study here, we can get a report from here, in which from general info we could see the summarize on the buses and the power grids and the branches that we use on this power system. And the load how many megawatt and how many megawatt we can see, and the generation and the losses. So actually the losses is quite not that worst situation and a mismatch, and we could see the bus result from here. Yeah, and from base case here we can choose the adjustment and the loading, in which we can choose the bus minimum or bus maximum. So right now you see all the bus is the red color, in which the marginal is default, and as we choose the bus minimum, it will change to another color, in which it will show the indicate that bus is on a marginal or not. So the color will be default in this case. So from the load flow study, we can know each of the currents flow and how many watts flowing through the lumps and the bus. And then next I will move to the short circuit analysis, in which this short circuit analysis is the balance fault. So when you choose the base study, we can select the bus that we want to make it as the fault of the bus. The fault occur on this bus. So in this case, I choose the 710 and 737, in which it will make the color differ here, the red color. So when we make it at max, so when we make it at max, so we will show the information here. We can choose the minimum. So when we choose the minimum, it will change the value to the minimum fault that will occur. And this is the 3-phase device study. So when we choose it, it also will appear the currents that will appear in this bus, the short circuit. So I will move on to the unbalanced load flow study, in which is this label. So when we choose it, and we can run the load flow study by using here, run load flow study, unbalanced load flow. So when we choose it, it will occur the information on each of the bus and the transmission line. And this is the unbalanced load flow study. And we can choose the study case here, like before. We can choose the minimum, maximum buses. So it will change to the value accordingly. Yeah, it will change to the volume accordingly. And next, we're going through the unbalanced short circuit here. When the unbalanced fault clicked, so we can adjust our study case by setting the shunt faults or the simultaneous faults. And in this case, I will choose the bus 713 as a reference bus, and then OK. So the 713 bus, it will be the red color here. So when we run the circuit, run the device study, and bus 713. Let's see. So it will occur the value here, and then as we adjust to the unbalanced circuit, that the study case I put before, so it will be another situation in which we can set the simultaneous fault lagi, and another fault, simultaneous fault here. Okay. So when we put the minimum or maximum, so it will run the different cases. as we run it, so we can see the report here, and then to see the summary. Actually, it will generate the PDF file. So how do we can resolve the circuit fault? So actually we can resolve it, for example the short circuit analysis before, the balance short circuit. So the bus 710 and bus 737, and then we got the report here. Yeah, it will summarize the bus that occurs the fault here, and then when we export it out, the analyzer export. So it will generate the report here. Yeah, the Excel file, and then we can analyze the solution by this symmetrical current. By the symmetrical current here and the XR ratio to determine the suitable circuit breaker for this bus bar. So actually this tab is useful for us to get for each of the bus bar, how can we adjust it and get the nominal value, and to set up the circuit breaker for each of the line, because as we know, when the short circuit is occur, actually the need of power protections and the zone of each of the power protection zone is very important for us to protect the power system. So this analysis is very crucial for us to determine and identify the suitable circuit breaker. So that's all from my demonstration. So thank you very much.